Hi guys, so I'm back here with another tutorial of this third-person action game tutorial series, and today what we're gonna be doing is advancing in the animation part and in the camera. So just so that you so wait, so you know we're gonna start downloading a few animations. I found bunch of animations that I think are very interesting. If you put Great Sword in the example page, you find a lot of animations which are very interesting. And there is a pack here with 51 animations, which is quite cool. Since I think we can use them for this tutorial series, I think it's gonna be very useful to have them all, and then later we can select the ones we need. So FVX, depose 30 frames per second, and no keyframe reduction. Okay. Also, I'm gonna be downloading a model. I have been looking for models. I think this one is free, right? I'm not sure. Yeah, download the 3D model. So yeah, you need to be signed in to download the models. Yeah, I'm now signed in. So OBG. Okay, so we got these two things downloaded. The Great Sword. Oof, that is big, isn't it? And those are PNG textures, and they're gonna be very big. I don't care right now. So let's get it. In models, art, characters, folder, sword. Get these two. Here. Well, I'm not sure if you can. It looks like you can. You can get them from the zip. Great. So the textures and the source, the Great Sword, great skill, and the animations. No, that's not this one. So let's add another folder, animations. Let's move all the animations there. And let's import them. So yeah, with these we have all the animations that I think we're gonna need, and all them, and the sword model which we also need. So now, before we go on to adding animations, I think there is one thing we should fix, and it's the camera. It's very annoying. Yeah, this is. I mean, just following the character like that is very annoying. So the first thing I'm gonna do is fix the camera. So let's create a camera script, a play cam. And let's open it. Yeah, there we go. So script controlling the camera that follows the player. So we're gonna do something similar to what we did in the tanks camera tutorial. I'm not gonna spend a lot of time explaining this, because if you are interested, please go to that tutorial where I explain that more in depth. So I'm just gonna be doing it again. I think it's gonna be good for you, so you see it again, but again I'm not gonna explain a lot of it. So first the ideal default offset is gonna be something like 0, 3, and -5. Yeah. Target default offset, so yeah, 0.0, 2.0, 50.0 for instance. Then yeah, we're gonna be sorry. Let's see. Let's well, we need to set the target. The transform, for instance. We follow char, for instance, or even char character. Let's call it character. Yeah. So the character is something that you're given. Let's calculate the ideal position. Oops. Okay, so yeah, there we have. This returns the ideal camera position. That's gonna be the character transform point default offset. Actually, yeah, I'm not sure we need a function for that. So maybe we can do a yeah, let's set it like that. Well, let's do a debug assert. So here we go. And we can set the position. It's gonna be and the default. So this is gonna be the default ideal position. The target position is gonna be the ideal target position all the time. We're not gonna be doing something smart with that. We're gonna change this, set it to void, and then we're gonna do target pose is character transform point default target default offset. Okay, so transform, look at target pose. Okay, so now this is setting the position to the ideal position all the time. Just we're gonna be doing that for starters, just as an initial version, and then we'll add the spring functionality. Go. Yeah, so let's do that. Let's use this one. Get it. Gameplay camera. The character is gonna be Jamo. Good. Now, let's see. Yeah, it's yeah, obviously it's not the nice camera. This is gonna be like 1. It's gonna be like 2. Let's see how it works like that. but still, I mean, yeah, far from ideal. Let's well, let's do something else. Let's start adding some so there's a spring, so it doesn't move instantly. Uh, I think those are reasonable values, but we will see. So let's make it all in a function apply spring to come. So yeah. This is so yeah, we're gonna need this is an ideal pose, right? Vector 3 campos, which that's what we're gonna update there, and then we're gonna also need a vector 3. Yeah. So first we calculate we apply the dumping. And this we need the delta time. So time factor is going to be math f clamp 0, 1, 1.0 minus dumping times dt. Bell I times damper factor, that's right. Now calculate the spring acceleration. So that way the offset to the ideal position, which is minus the current camera position, which is the current transform position. Then basically this is the axle is gonna be the ideal position offset times the spring K, and then we apply this acceleration by simply vel plus equal the spring axle times delta time, and with the new velocity update the position. Finally, make sure the position is not too far from the ideal position. So in case it's gone further than a maximum distance that we can find here, let's say vector 3 max dist from ideal pose is going to be I don't know, in X we can have like 1.5, in Y we're gonna reduce it to 0.5, and in C 1.0 for instance, I don't know. So so we're gonna recalculate the ideal cross offset, and we are gonna convert it into local coordinates, which Okay, so now maybe what we may want to do is character inverse transform point campus. So this cam offset local. This is the offset in local coordinates. Local ideal offset is gonna be offset local minus ideal default offset. This is basically yeah. So we are removing the default offset, and then we have the local ideal offset. Now we limit it, so local ideal offset of x is local ideal offset of x minus max this from ideal offset of x max least from ideal offset of x, and same for y and z. Yeah, and once we have this, we convert the local ideal offset to, so we recalculate the cam offset local. So it's gonna be the default plus the local ideal offset, and recalculate the camera position. Is gonna be a character transform point cam offset local. Good. Well, let's see if it works. Well, it doesn't, because we are not using it. Obviously it's not working as expected, so yeah, maybe it's because I mixed them between 10 and 5. Yeah. Oh, oops. Oh, that's because it's got 0. Maybe also because it moves very quickly. Maybe if the character had a lower movement speed, but it still goes. It's not very so the camera maybe can reduce the damping to 3, maybe, I don't know. Maybe we can increase the spring K. Let's reduce this to 120. Let's increase this to 4 and this to 13, for instance. I don't know. So 5 and this be 12, for instance. That's better. That looks better. Yep. But still, you know what? I don't like it like this. I like to use the mouse to move my character left and right. You know, so it's to rotate my character left and right. So let's do that. Let's go for that. The player controller, I believe there is a mouse. By default there is a mouse X. Yeah, mouse X. Let's use that mouse X movement, maybe we'll multiply times a constant. So instead of using these, we're gonna use mouse X. And yeah, let's use it just like that. Thing is, we don't want that. We want more than that. We want something that basically, when it moves, well, maybe if we're doing it like that, I don't know. Let's instead let's do something like cursor lock state locked. Let's lock the cursor to the center of the screen, so it doesn't move out of the screen, which may be useful. Obviously, with that, yeah. What we can do here is we can increase the movement a lot in the character, say to 60, for instance. It's a little bit too much, and maybe we can reduce in the player controller this input. So 1 times a factor, like which could be something probably 0.5, for instance, like a fourth of what you get. Oops, I said clump 0.1 when I want is clump minus 1.0, 1.0. Yeah, and this is probably too low, maybe 0.5. I don't like it. I don't like it because it's very rough. Like you cannot like when you move, it kind of like moves very quickly, particularly at first. So maybe I could add a well, we could simply, instead of using get axis raw, we can use get axis, which is gonna be the easiest way. We could add some acceleration to the rotation. That's annoying, particularly. Still got the same problem. Yeah, probably because the inputs are very the same as raw. So maybe we need to add in the move controller. We can add a rotation angular velocity, angular acceleration. For instance, and we can actually so we can use that to set the maximum angular velocity. Which should be 0. So if we want to rotate, let's update the maximum angular velocity. So float ideal and vel is gonna be these. if ideal and then we do something like abs ideal angular velocity is going to be the absolute value, because we don't care whether that's positive or negative. And what we're going to do is we're going to do an acceleration or deceleration towards that target. So max angle offset is going to be a well minus max angular velocity. So max angle offset is going to be clamp. We're going to clamp it with minus acceleration times the t, acceleration times the t, and max angular velocity plus equal max angular velocity offset. With that, we're using the same concept but to the maximum angular velocity. So this should make the rotation at first more precise. I find that the character still can move quite a bit. Possibly it's the camera too. So maybe we can reduce this to 0.75. I think this is better. This is better. It looks good. Still fun. Sometimes it kind of jumps. I think we need to do a better check of the inputs with the mouse and so on. But no, I'm not gonna be doing it right now. So yeah, now if this is the case, now one of the things that we can do is, it works. Yeah. One of the things that we can do is, by the way, the character controller will jump the moment the offset is small enough. Yeah. So we can also strafe left and right. We can move left and right without rotating. It's something that we don't have now, and so that means that we have to change this. We have to add a we're gonna rename this to move inputs, and there's gonna be a dot inputs, which we're gonna be using a vector 2, because later we may want to add the rotating up and down. So basically what we're doing here is instead of using move inputs, we're going to be using rot inputs. And here, so what is going to be the ideal velocity is going to be move inputs y, but not so yeah, this is going to be vector 3. So ideal speed c float ideal speed x move inputs with x then max speed. Yep. What we do is ideal speed plus ideal speed x times right. Um, Actually, no, we're gonna calculate right as vector 3, cross forward new vector 3, 0.0, 1.0, 0.0, because that way I'm pretty sure that right is orthonormal with forward. I'm not sure if this is going to be right or left, so let's see. Let's see if this one works, and if not, we just swap forward with up. Oops. Yeah. Let's go move inputs, which is gonna be we're gonna do the same as with mouse Y. Yeah. Let's see. So, well, it swapped. I'm sorry, but yeah. As you can see, we can move left and right, forward and backwards, and we can rotate the camera. Great. Yes. But this one is the other way around. And this is good. We have now a camera and we have a rotation. That's good. I think we're gonna be leaving it for today here, and in the next one we're gonna be adding some animations. I think that if I start doing it now, I think it's gonna be a little bit confusing, so I'm gonna leave it here for now, and we'll go on in the next video. Hope you guys enjoyed it, and if you liked it, please hit the like button. I hope to see you guys in the next video. Bye.